Welcome to this screencast about load balancing web servers. In this screencast I will explain how you can have better availability for all your web servers. Let's start with solving your availability problems. In a normal setup, all your clients connect directly to the web server, like in this image. With this setup, you have a single point of failure. If the web server crashes, the client is unable to see your site. That is why we are going to use load balancers. Instead of connecting to the web server, your clients are going to connect to a load balancer. A load balancer keeps track of your web servers and their status. When a server crashes, the load balancer connects your client to a web server that is online. In this example, we are going to use HAProxy as a load balancer software. Let's start with the configuration of a simple load balance environment. Let's install HAProxy on the Debian server. There's a package available, so it's easy to install through apt-get install HAProxy-y. The install goes very fast, and let's look at the configuration files that is present on the server. We only have one configuration file, haproxy.cfg. You can open the configuration file with your favorite editor. In my case, this is Vim. So let's type vim etc haproxy haproxy.cfg. We can delete everything in this file. In Vim, this is very easy. If you're at the beginning of the file, like we are right now, just press D and capital G. At this stage, we can start with configuring HAProxy with the basic load balancing configuration. We need to enter a global configuration, and we are going to say to HAProxy, you run as daemon, so just run in the background. Then we have a defaults block. All the settings in this block will apply to all the other configurations. So we are going to say mode of HAProxy is HTTP. In HAProxy you have multiple modes. You have HTTP mode and TCP mode. TCP mode will just set up a raw TCP connection when the server is available with the port as well. HTTP mode will make a reliable connection on a layer 7, and they will check if the connection is RFC compliant. Right now we are going to create the front-end block, so there's the entry point for all the clients which need to connect to that specific block. So we are going to type front-end, then giving it a name, for instance HTTP in, because all the incoming or inbound traffic from HTTP will flow through this. Then we are binding this to a specific IP address. It has to be an IP address that's attached to this server. That on this server is 10.0.0.101 on port 80. Everyone connects through this block. We need to redirect them to the web servers, and we can do that with the statement default backend web servers. Right now we need a backend called web servers because we already used default underscore backend to redirect all the front-end connections to the backend. So let's create that. We type backend and then we choose the name. In this case, it's web servers as well, because default backend is redirecting automatically to the same name as the backend, called web servers. For the configuration, we are going to add all the possible web servers we have. To add your servers to the backend, you just start with the keyword server, followed by the hostname of the server, web server 1, followed by the IP address, that's 10.0.0.111 on port 80. And then for the second web server as well. HAProxy supports multiple balance algorithms. The balance algorithm is necessary to redirect the clients to a specific server. The three algorithms I'm going to explain are the round-robin algorithm, the least connection algorithm, and the source algorithm. The round-robin algorithm is the simplest one. They are just going to select each server in its turn. So one time it's going to swap 1, second time it's swap 2, and so on. The least connection, or the least con balance, is the balance that is used with the least connection at this very moment. This is very helpful when you have a server with long connection times, for instance for an LDAP server or an SQL server. The last balance that you can use is the source connection. Source connection is to assure that all the clients who are reconnecting to the web server keeps going to the same server. For instance, if you have a web shop, you want the customer to, if they reconnect, always come back to the same server. We're going to use the round-robin algorithm. In fact, that was the last option and the configuration we needed to add to have a basic load balancing mechanism. We can save the configuration and we can restart HAProxy. Let's go to the web servers. We can still connect to web server 2 and to web server 1. We are not going to accessing the web servers directly, but we are going to access them through the load balancers. So the IP of the first load balancer is 101. We're going to connect to it, and like we see, we are connecting immediately to web server 1. When you refresh the page, we are going to web server 2, web server 1, web server 2, web server 1. As you can see, we're connecting through the load balancer, and it's giving us the round robin algorithm like we configured. And every time we refresh the page, we're getting to a new server. Right now we have a very basic load balancing mechanism. In the next step we will explain advanced configurations, how we can introduce health checks if one web server crashes, the other takes over, and a backup and a slave state. We also can introduce a health check on a specific file on the web server, so if that file is not available, the other server takes over. That's very helpful for maintenances and so on. Right now we achieved basic load balancing. It's not very advanced, not at all in fact. Also, when a server or web server crashes, HAProxy will still try to connect to it because it's not performing any checks if it's up or down. So it's assuming it's always up, it's always online, there's never a hiccup, and so on and so on. Right now we added some extra configurations, but we didn't add extra functionality to the load balancing itself. Right now we are going to add a statistics page. We can do that by adding a listen block. A listen block in previous versions was actually the same like a front end and a back end, but the front end and back end has a better overview and so on. Let's add a listen block. We say it's for the statistics, and we're going to listen to a specific port 1936. Then we're going to say enable the stats. We can hide the version. This is a security measure to prevent version related exploits. Then we are going to give it a name. For instance, load balanced servers. We add a backslash to escape the space. Then we are going to define the URI. You can add anything you want. We are going to go with the defaults, and that's HAProxy !stats. And then we are going to eventually secure this with some authentication. The username is HAProxy, the password is HAProxy as well. You can add anything you want in a production environment. Please do not use HAProxy, but use something more secure. You also can use an encryption function and HAProxy. Right now, that's actually all you need to do. Let's save the configuration file and restart the service. Let's go to the browser and connect to the statistics page. So that's 101, the IP of the load balancer with the port 1936. Then we immediately add the URI, HAProxy !stats. Then we are going to authenticate ourselves, HAProxy. Then we enter the statistics page. Let's give it a quick overview of what you can see. We just restarted the service, so we have a low HAProxy downtime. We only can have 2000 max connections at this very moment, but for this screencast and educational purposes, 2000 is more than enough. But for a production environment, you can actually set this till 10,000, 40,000. That's depending on how much traffic you expect. And HAProxy is 100% idle, so it's not doing anything. For the statistics, you can see the sessions. We only have one session. If we refresh the page, we can see the sessions are going up because we always connect again to it. So then we have the incoming block, the HTTPN. That's actually the front end. Here you can see only if there's a current session state. If someone is connecting to it right now, you can see it. And then the web servers, how many times did we connect to the web servers. This statistics page refresh every time you reset or restart HAProxy service. So as you can see, this is 0. And if you go to load balancers and we refresh a couple of times, then we refresh the page, you can see we connected 9 times to both of the servers. I skipped a little bit of this legend. The colors is active up, going down. I will show this in a later video, but right now this is gray because HAProxy is not checking the health of those servers and is assuming they are both up. This is a little bit dangerous because it's possible web server 1 crashes and then HAProxy still wants to connect the clients to web server 1 when it's down. So that's not the best practice of HAProxy. So we're going to add some checks to it. Right now the statistics page of HAProxy is working, so we can see the health of it on a nice overview and a little web page. What we are now going to do is implement some extra health checks. Right now we are just checking. And for instance, if we disable the Web02 Nginx version, it took a little bit before HAProxy knew that it was offline. So we can speed up this process by telling HAProxy his health intervals or his health checks needs to be more frequent. Then we just say enter from interval in milliseconds, 500 milliseconds. So HAProxy is going to check the web server every 500 milliseconds if it's up or down. Then we are going to say, alright, HAProxy, you can consider the web server down if the health check fails for 3 times. For the reason that sometimes an HTTP connection can be dropped by HAProxy if there's too many connections at once. So if it fails 3 times, then we can consider it server is down. Otherwise, HAProxy will say to the server, alright, you're down, if it's 1 time failed to set up a connection. That's not nice at all. So, and then we can say, alright, you can go up from a down state if the health check was fine for 2 health checks after each other. And we are going to say the same to the second web server. Right now we are going to add an extra feature, that's an HTTP check, and we are going to say to HAProxy, if the file we want to check is available on the server, then that's fine, you can put the state of the web server up. If the file is not found on the web server, then you can say to the clients, this web server is offline. This is very helpful if you want to do some maintenance to the web server and not shut down Nginx at all. So let's add that. Say option HTTP check. We perform a get on the file HAProxy._check. And this file name, HAProxy_check, can be anything you want. So if you want it's your company name, that's fine. If the file is not available, HAProxy will not distribute this web server to all the clients. We can save it, restart the service, and let's check the statistics page. If you see both of the servers are down, the reason for that is you see there's a 404, so the file we entered that needs to be checked for the HTTP check is not available. You can connect to the web servers, yes, alright. And we are going to add the file HAProxy check just by touching it, by using the command touch HAProxy_check. So we added this file. And now if you refresh, we can see web server 1 is up because the file is found. We can do exactly the same thing on web server 2. If you touch it as well, HAProxy check, and we refresh, web server 2 is available as well. So for instance, if you want to perform some maintenance, just remove the file, and the server is going down. As you can see, it's the yellow color, active server going down. And now it's down. So let's add it again. This is a very useful feature and should be used every time when you perform a maintenance instead of just dropping the Nginx server. We still have one problem. If the load balancer crashes, the clients are unable to reach the web server. This can be fixed with 2 load balancers. We are using Keepalived to monitor this. Keepalived has a virtual IP address which is automatically assigned to one of the load balancers. When the primary or the first load balancer crashes, Keepalived notices that and will switch the virtual IP address to the second load balancer. With this method, you still have a load balance environment even when one load balancer crashes. Let's install Keepalived. Keepalived is also available in a package and is installable through apt-get install keepalived-y. The installation is fairly fast, just like HAProxy. And if you check for any configuration files, you will notice that we do not have any configuration file at this very moment. So we are going to need to create our configuration. Use your favorite text editor, that's Vim, or you can use Nano or whatever you want, and create a keepalived config and /etc/keepalived/keepalived.conf. Then we are going to do a little configuration. We need a script and an instance. The script will check if HAProxy is running, and when HAProxy is still running, then the server stays the master. But for instance, when HAProxy is not running anymore, then VRRP, the protocol, will tell the other server that HAProxy is not running and that this first server, LB1, should become a backup server and the other should become master. I will demonstrate that after configuration. So we are going to create a script. So we have vrrp underscore scripts, and then we can give it a name. We are going to name it chk underscore HAProxy. That's from check HAProxy. Do not forget your curly brackets. And then we're going to create the script PID of HAProxy. So we are going to check if HAProxy still exists to get the process ID. When PID of HAProxy returns the process ID, then HAProxy is still running. And we're going to check that every 2 seconds. So we do have the script right now. Let's create the instance. We do need a little configuration. We need to say what interface we are going to monitor. So we are going to monitor our default interface, that's ETH0. Then we are going to say to this instance, alright, this server is the master server. This needs to be the primary server. And of course we give it a virtual router ID. The virtual router ID is an identification between the two load balancers. These two virtual router IDs needs to be the same. If it's not the same, they don't interact with each other, they don't exchange VRRP information with each other, so there won't be any failover when that's necessary. Then what's really important as well is the priority. For the priority, the master needs to be one higher than the backup, or needs to be higher in general than a backup server. We're going to use 101 for the master server, that's this server. For the other server, we will use 100. Then we are going to use a floating IP like I explained before, so that's a virtual IP address. And then we are going to say the virtual IP address is 10.0.0.100. This IP address can basically anything that's available in the subnet range. Then we're going to say to the instance, alright, you need to track the script. And we are going to track the script we just created, and that's thk underscore HAProxy. So this instance will track the script HAProxy to see if it's still running. All the clients are now connecting on the floating IP, so that's 10.0.0.100 instead of the load balancing 1 machine. So that's the first configuration. Let's create the second server configuration. Let's save this config. We just created the Keepalived configuration. The only thing we need to do is restart the Keepalived service. And that's it. Now we need to connect to the second load balancer. That's 102. Log in with root. Then we are going to need to install Keepalived as well. Keepalived. And then we are going to create the configuration. So, like I said, we can copy paste the configuration from the preview server, and we're going to adjust the state from master to backup, and the priority from 101 to 100. So the backup server needs to have a lower priority. That's it. We can save the configuration and restart the service. After all the configuration on the Keepalived part and HAProxy part, the only thing I need to show you guys is how Keepalived works. Like I explained before, Keepalived works with a floating IP address, and all the clients should connect on the floating IP address instead of the load balancing machine. You can see on the first load balancer or the second load balancer that it only has its own IP address and does not have the floating IP address. When you check the first load balancer, we clearly see he has his own IP address and also a second IP address, and that's his floating IP address. Floating IP address is configured through Keepalived. So what happens when Keepalived crashes? Well, in fact, through the VRRP protocol, they communicate with each other, both load balancers, and they say, alright, I'm down, now you can take the floating IP and advertise it for everyone. So we're going to set a little watch on the IP address, and we are just going to shut down Keepalived on load balancer 1 and see what happens. In 2 seconds time, when he did a check on VRRP, you can see that floating IP address adjusted from server 1 to server 2. The client didn't notice anything of this. They still can load balance between the web servers without any interruption. Unfortunately, we reached the end of the screencast. Right now we do have a fully redundant and load balanced environment. Thanks for watching and see you next time.